Purpose and origin of Cold War. The origin of the Cold War isn't very clear. While most historians think that it is a consequence of the Second World War, others believe that the Cold War started with the October Revolution in Russia from 1970. The Bolsheviks tried to gain power in the region and invaded other countries. However, this couldn't be fulfilled as they needed to keep peace up with Germany. In 1980, Great Britain sent forces to Russia in order to stop the Bolsheviks and restore capitalism in Russia with the white counter-revolutionaries. However, the Red Army defeated them and communism was established in Russia and small neighboring countries. Soviet Russia saw itself surrounded by enemies and isolated itself from the rest of the world. Lenin tried to promote communism worldwide but failed miserably. In the 1930s, Lenin developed a plan with capitalist nations to prevent fascism to spread in Europe. However, he was betrayed and Nazi Germany had full control over Czechoslovakia. After this conflict, Lenin signed contracts with Nazi Germany and started invading nearby countries. After the Second World War, tensions rose in Europe. The USSR and Great Britain had conflicts in Iran, the reason being that they didn't trust each other. Lenin answered with a call of war in English-speaking countries. This led to the so-called Cold War between the USSR and the US.
The space race during the Cold War was a good pretext for the United States and the Soviet Union to show their strength without having to fight in an armed conflict. The two countries couldn't fight each other in a real conflict because this would have led to a nuclear war, so they decided to show which country had the best scientists. The fact that both set themselves the same goals made it even easier to compare them in the context of space exploration. Chronologically, they tried to launch the first human satellite into the Earth's orbit, then sent the first human to space, and finally land the first human on the moon. These two objectives were accomplished by the Soviet Union, with respectively Sputnik 1, which means traveler in English, and Vostok 1. The launch of Sputnik 1 of 1957 rang an alarm in the United States, and President Dwight D. Eisenhower created the NASA the next year. The NASA became the official showcase of America in terms of spatial exploration, while two other agencies were used in military context. First, the Air Force trying to launch missiles with information gathered by the NASA, and secondly, the National Reconnaissance Office, which used satellites to collect data about the Soviet Union. The space race finally stopped in 1972, when the Soviet Union abandoned their dream to launch a lunar landing craft after 4 failed attempts. The USA were decided as winners as they already sent a mission to the moon in 1969.
The consequences of Cold War. The Cold War is the consequence of the Soviet Union's victory over the Nazis. Truman wanted a global containment of communism. The tension increased and caused the division of Europe, where the most famous example is the Berlin Wall. It divided Berlin from 1961 to 1989, which symbolized the barrier of West and East, so the Federal Republic of Germany and the German Democratic Republic, GDR. George Orwell had an outspoken support of democratic socialism and defined the Cold War as peace that is no peace. The Cold War gained popularity due to the famous journalist Walter Lippmann. He explained the meaning of Cold War, and the world quickly had to choose their side in an ideological fight between capitalism and communism. Economically, the consequences were important after the Cold War. When the Soviet Union opened its borders, it increased their GDP to $2.25 trillion, which is the equivalent of 45% from the US national products after Cold War. The political powers of space exploration. The space law is a collection of domestic and international agreements and guidelines that govern issues like space exploration, military and revenues. We see that it uses the astronomy and space technology to explore outer space. Common traits for exploring space include advancing scientific research, national prestige, uniting different nations, ensuring the future survival of humanity, and developing military and strategic advantages against other countries. Space exploration is also seen as a competition for geopolitical rivalries, such as Cold War, for example, The early era of space exploration was also driven by the space race between the Soviet Union and the United States. The impacts of going to space. Going to space can lead to humans having a few medical issues, as we aren't meant to live in this habitat. Furthermore, we know that going to space requires special training for the astronauts and special equipment, which can cost a lot of money, as we can see in the economic issues. We can see some consequences of living in space. We can observe negative effects on the human body, which can conclude a slowing of the cardiovascular system functions and decreased production of red blood cells, but also balance disorders and changes in the immune system. In addition to this, these symptoms may include fluid distribution, the moon phase. This is an appearance typical in pictures of astronauts. Completing this challenge is trying to understand the effects and impacts of long-term space travel on the human body and access fluctuance. Most engineering problems are first associated with leaving Earth, and then developing space propulsion systems have been examined for over a century, and millions of hours of research have been spent on them to avoid problems. Nowadays, there has been an increase in research on the issue of how humans are able to survive and work in space. The research requires input from the physical and biological science and has become the greatest challenge of facing human space exploration lately. An important step in completing this challenge is trying to understand the effects and impacts of long-term space travel on the human body. After Apollo 11's landing on the moon in July, there are 6 more Apollo missions, which followed by the end of 1972. Members of the crew of Apollo 13, which was the most famous one because they managed to survive the explosion of the oxygen tank on their way to the moon. And the final space shuttle mission happened on the 21st of July in 2011, when Atlantis arrived at the...
Talk about money. In this case, the money that is allocated to the different space agencies all around the world. The easiest one to start is the NASA, because it is the space agency of the USA exclusively. In this graphic we can read that during the Cold War, more than 4% of the annual budget of the USA was used by the NASA. Since the man landed on the moon, the budget has been decreasing until now, where it is less than 1% of the annual budget. However, this still represents a lot of money for the citizen, because the annual budget for 2019 is $19 billion. This means that every American citizen would have to pay $57 per year for the space exploration. In Europe, it is completely different because the ESA is a grouped space agency where every country participates based on the number of European citizens it has. Based on the ESA calculation, every European citizen gives €11 to the ESA per year, which is about a fifth of what the USA citizen pay. This clearly shows the difference in ambition between the USA and Europe in terms of space exploration. Exceptions in this list are countries that invest money in space exploration outside of the ESA. This is the case, for example, in France with the CNES. Because the CNES has a budget of €2.5 billion, the French population pays on average €37 to space exploration instead of €11. During the space race, citizens of all countries have seen humans going up to the stars. Surely this created lots of creativity for authors and permitted them to imagine their own versions of these events. 2 songs that retained our attention are Space Oddity from David Bowie and Rocketman from Elton John. The first song talks about an astronaut flying through space in his rocket. The other song, Rocketman, is inspired on the novel The Rocketman from Ray Bradbury. This song was one of Elton John's greatest hits, so that his biography movie was named after it. Talking about movies and blockbusters, there are multiple entry points. The first one to have an enormous budget was 2001: A Space Odyssey, published in 1968. When talking about space exploration, it is impossible not to mention Stanley Kubrick's movie, because it shaped the way of filming space. 1 decade later, George Lucas publishes his movie Star Wars. This movie created such a hype that the medias were talking about a dangerous mass phenomenon. Despite the much smaller budget than Kubrick's movie, he did a nearly perfect job and revolutionized science fiction movies. Honorable mentions that we could add to our list are the line,
Houston, we have a problem.
in the movie Apollo 13 of 1995 pronounced by Tom Hanks, and the catchphrase,
To infinity and beyond!
from Buzz Lightyear in the Pixar movie Toy Story of 1995.
At the beginning of the 16th century, mankind had only observed 8 bodies in our solar system. These bodies were Sun, the Earth, Moon, Mercury, Venus, Mars, Jupiter, and Saturn. With scientific research in the early stages of development, people still thought that the Earth was the center of the galaxy. In 1610, Galileo Galilei started to experiment with telescopes and expanded the knowledge about our universe. He was born in 1564 in Pisa and died in 1641 near Florence. He was an Italian scientist, astronomer, physicist, and engineer. In the late 17th century, Nicholas Copernicus' theory of a heliocentric system was accepted by nearly everyone, and the discoveries in our solar system started to grow rapidly. Copernicus was born in 1473 and died in 1543. He was a German and Polish scientist. At the end of the century, 9 more celestial bodies had been located. 4 of these celestial bodies were moons of Jupiter, discovered in 1610, and the remaining 5 of them were moons of Saturn, being discovered between 1655 and 1684. In the 18th century, 1 more planet was discovered in our solar system, Uranus. Uranus was discovered in the year 1781 by William Herschel. He was born in 1738 and died in 1822. He was a German astronomer. 6 years later, Herschel discovered 2 of Uranus's 27 moons, and in 1789 he discovered 2 other moons of Saturn. The 19th century saw a rise in the discovery of new celestial bodies. It is seen as prime time for stellar discoveries, with over 450 celestial bodies being discovered. However, only 9 of them were big discoveries. Neptune was discovered in the year 1846 by Leverrier, a French astronomer, including one of its moons, Triton. Furthermore, during the century, there were a lot of discoveries regarding natural satellites orbiting Mars, Jupiter, and Saturn. In the 20th century, the discovery of our solar system reached its peak, with more than 40 noteworthy objects being detected in our solar system. One of them was Pluto. Pluto was discovered in 1930 by Tombaugh, an American astronomer, being the last planet to be discovered in our solar system. However, today it is unclear if Pluto still counts as a planet. Afterwards, the golden age of space discovery started. The launches of the Voyager 1 and Voyager 2 probes made it possible to discover small space rocks between 1979 and 1990. Voyager 1 is still on a course which leads outside our solar system into the vast unknown of interstellar space. On October 12, 1915, the closest star to our solar system was discovered by the Scottish astronomer Robert Innes. He discovered Proxima Centauri, a red dwarf star, one of 3 stars in the Alpha Centauri system. Alpha Centauri was initially discovered in 1839, being the first binary system to ever be discovered. As Proxima Centauri orbits Alpha Centauri, it is listed as the closest star to us, being 4.3 light-years away. However, it is still not known if Proxima Centauri is a part of Alpha Centauri or if it is a star system on its own. There's only one known planet in the Alpha Centauri system, Proxima Centauri b. It orbits Proxima Centauri in the habitable zone. It is the most Earth-like planet to ever be found. However, we do not know if this exoplanet is habitable. First evidence for the exoplanet was found in 2013, and in the year 2016 a project called Pale Red Dot was launched by ESO to confirm its existence. Alpha Centauri could be the target for upcoming unmanned mission, with new technologies cutting the travel time from millennials to just some decades. This could lead to a more in-detail exploration of Proxima Centauri b and the rest of the system. The discovery of the first exoplanet. Michael Mayer and Didier Queloz, 2 Swiss astronomers, discovered the first exoplanet in history, 51 Pegasi b. orbiting around the star 51 Pegasi. Given the planet's very short orbital period of 4 days, MAIOU and Queloz were not sure if their discovery was legit or not. When they found 51 Pegasi b, MAIOU and Queloz didn't quite grasp the importance of the discovery. Only after the discovery got a huge media coverage and their nomination for a Nobel Prize, they understood what their discovery meant. They continued their observation for a time before confirming their discovery. The planets were found using the Doppler spectroscopy method, which we will talk about later. The discovery methods. Exoplanets are far too small and too far from Earth to be able to see them with a telescope. Therefore, astronomers had to invent other ways of finding planets through the universe. There are two main methods to discover exoplanets: the Doppler spectroscopy and the transit photometry. The Doppler spectroscopy is the most used technique. By studying a star's movement through space, scientists are able to determine if the path is altered by any other smaller objects, in this case a planet. Once they know that there is a planet altering the star's path, they have to study how much it does so. With this method, astronomers will find the planet's mass. The transit photometry permits the astronomers to find a planet's size. Every planet orbits around a star, and as such, every once in a while it will pass between the star and our point of view. By analyzing how much the star's brightness is dimmed during the eclipse, they will be able to calculate the planet's volume. Once the mass and the volume are known, the astronomers can calculate the planet's density and theorize about the planet's composition.